All right, so today's notes are on skeleton equations. How can we get the structure of a chemical equation? So if you think about the skeleton of our body, its whole purpose is to give us structure. It keeps us upright. Right? If we didn't have it, we'd be like a puddle on the floor. Right? It's our backbone. So we need to be able to make sure we can get our backbone of our chemical equations before we try to balance them. Because if your skeleton is wrong, we won't be able to go any further. So what is a skeleton equation? It includes our molecules, compounds, elements, our plus sign, our yield arrow, and states of matter. That's it. If you notice, right, it has no coefficients, and it is not balanced. Skeleton equations don't have to be balanced. So here's our example. We have an Al plus Br2 yield an AlBr3. What we do need to check is to make sure that there are elements on both sides of the equation. So when you're done with your skeleton equation, we always check ourselves and we say we have an Al on the reactant side, an Al on the product side, a Brs on the left, Br on the right. You kind of think of the arrow as an equal sign, although it does not mean equal. But what's on the left has to equal on the right. If you notice, this Br has 2, this Br has 3, so we would call it unbalanced. But that does not matter to skeletons. We're not there yet. So I like to solve skeleton equations in 2 steps. Okay? It helps me process a little bit better and make sure I don't miss anything. My first step is to write the elements with their charges. Okay? You're going to get a word problem. When people see word problems, they get nervous, they freak out. It instantly becomes 10 times harder. But with this, we're simply going to take our elements and write them with their charges. Okay? The only exception is if it gives us a prefix. So like carbon dioxide, that prefix tells me it's a covalent compound, meaning I don't need to look at charges. So if it uses prefixes, don't worry about the charges. Just write how many there are. And step 2 is swapping and dropping. Now, our exception is if an element is by itself. If it's not connected to anybody or another element, right, ignore the charge, right, and then we're going to check to see if it's diatomic. These will make more sense when I do some examples. So example, calcium fluoride and potassium produce calcium and potassium fluoride. So step 1 is to write their elements with their charges. So calcium I know is Ca, and I would look on my periodic table and it tells me +2. Fluoride, it ends in IDE, but I remember that's the same thing as fluorine. Okay? So that is an F. It has a -1. For and, I'm going to put a plus sign. Potassium is K -1. Just kidding. That's a +1. Produces, that's going to be our yield sign. Calcium, which I know is Ca +2 because I used it on this side, and is our plus. Potassium and fluoride. Now, when you get to your products, it's a little bit easier because you know you'll have to be using what's on the reactant side, so you won't have to look at those charges. But again, I always like to double check to make sure my elements are on both sides. So here's Ca +2, Ca +2, F -1, F -1, K +1, K +1. So I'm good to move on to step number 2, which is swap and drop and check if diatomic. So remember, with swapping and dropping, ones do not matter. So I'm going to go ahead and scratch out my ones. And then if it's connected to an element, my charge is going to swap and drop. So I'd write this as Ca. F will now have a 2 down low. Okay. This element was by itself, so even if it didn't have a 1, we don't care with the charges. Ca, this Ca is also by itself, so since there's no one to swap and drop the charge with, it goes away. And then Kf. So that would be our equation. And next we have to check if it's diatomic. But we haven't talked about that yet. So let's see what we mean by diatomic. Diatomic molecules, there are 7 of them. Bri and Cl, H, O, and F. Okay? It spells out the word Brinkelhoff. Okay? That word doesn't make any sense. It's kind of fun to say, Brinkelhoff, but it's a way to remember. Some people make up a sentence using those letters. However, it will help. They also form a 7 on the periodic table, because if you look, nitrogen, oxygen, fluorine, chlorine, bromine, they form a 7 plus hydrogen over here. But it means that you will always write it as X subscript 2 whenever it is by itself. Okay? Because they have 5, 6, 7 valence electrons and they're trying to get to 8, okay? They're always going to pair up with themselves to get to that noble gas notation. Okay? So O will always be written as O2 if it is alone, but it could just be MgO without that subscript when it's in a compound. Okay? It's never going to be a single O. So looking at it, when the O is by itself, it has a subscript. When it's with a compound, you check for swapping and dropping. Again, this O, if we look, has 6 valence electrons. Right? It just needs 2 more. So when another oxygen comes around, okay, they're going to share their electrons. Okay? And so they're going to combine with each other. We didn't have to draw these. But they're going to bond with each other, and now they have 8. Okay? That's why we call them diatomic. So let's look at example 2. So step 1, let's figure out our elements and charges. Aluminum is Al, it's +3, and sulfur, which is a -2. Combine to form, that'll be our arrow. Aluminum, which I know is Al +3. Sulfide, which is the same thing as sulfur, which I know is a -2 charge. So double checking, Al is on both sides, S is on both sides. So I move on to step 2. Swapping and dropping. Al is by itself. There's no one for this 3 to swap with. Okay? These are separated by a plus sign, so they can't cross it. So this will just be Al. Again, this S doesn't have anyone to switch with, so it goes away. Okay. This 3 will come over here. This 2 will go over there. And so this will be Al2S3. Now we'll check for diatomics. Okay. Al and S, Brinkelhoff. Neither of them are involved with that. So we're done. So this would be my equation. Al plus S yields Al2S3. From there, later, we'll learn how to balance. If we do example 3, solid barium, right, so that tells me Ba, which is +2, and it's telling me it is solid, so I'm going to write solid for its state of matter, and oxygen gas, react to produce, so that's my yield, solid barium oxide, so Ba+2, oxide is the same thing as oxygen, and it's also solid. I know a chemical reaction took place because I took a solid and a gas, they combined and they formed a brand new solid. So step 2, let's swap and drop. Ba is by itself, so I don't care about its charge, so this will just be Ba. Oxygen is by himself, so we don't care about his charge either. So we could swap and drop these, but I remember if they are the same charge but opposite, they cancel. So this is going to be BaO. Now, if we check for diatomic, Ba is not part of Brinkelhoff, but O is Brinkelhoff. Right? So that means we're just going to add a 2 subscript. And again, this equation is now unbalanced because there's two O's over here and just one on this side. But remember, balancing is not what we're worried about. We're just getting the elements and the correct subscripts. I'll work one more out. So solid iron, so Fe. Now, iron is transitional, meaning we don't know its charges. Right? Because it's not telling us a charge, we can look up iron. Iron normally has, I believe, a +3 charge. Okay? But since it didn't mention it, it means we don't need it. So I'm just going to ignore it. And aqueous hydrogen sulfate. So hydrogen sulfate is polyatomic, so I would look on the back side of my periodic table. Aqueous is AQ. React to produce our yield. Aqueous iron, Roman numerals. Remember, those Roman numerals are the charge of iron. Sulfate. And hydrogen. It didn't tell us what hydrogen was, but I know it's a gas. So there's step 1. So step 2, I'm going to swap and drop. Again, because iron is a +3 on this side, I would know that this would have to be +3 as well. They're not going to change their charges from products to reactants or reactants to products. But again, iron is by himself, so that 3 does not matter. This 1, I don't care about. This 2 shall swap and drop it over here. We could have also called this sulfuric acid. My 3 will go and my 2 will change. Remember, polyatomics, you cannot change. They're stuck together. So that 3 will go on the outside. 2 goes over here. My box turns into parentheses. Hydrogen's by himself, so his charge does not matter. Let's check for Bringelhoff on any single elements. Fe, not part of Bringelhoff. Hydrogen, Bringelhoff is, so we're going to add a 2. So there's that worksheet on Classroom. It's assignment 2 of Learning Target 2. Okay. It is on ClassKick for you to fill out there if you like, or of course you can do it on paper or .cub and upload it to that Google form. Okay. 1 through 4, I would like to see both your steps just to make sure you're doing it correctly. And then 5 through 8, if you can do it all in one step, do it in one step. Okay. But for 1 through 4, I want to see where you're writing it with the charges and then swapping them, dropping them correctly, just to make sure we're not getting any issues in there. All right. If you are confused or have any questions, feel free to shoot me an email.